Welcome to Microsoft Build 2017. I'm Donovan Brown, Principal DevOps Manager at Microsoft. In this video, I'm going to introduce you to Visual Studio Team Services and show you how we can use it to deploy any language targeting any platform. We're going to get started by simply creating a new team project. We're going to create a new team project from the dashboard. Anyone can go to visualstudio.com and create a free account. What I'm doing here is simply adding a team project to my account. Simply give it a name. Choose what version control you want. We both support Git and TFVC, or centralized version control. You can choose a different work item process or process template for Agile, CMMI, or Scrum. And you can even control who in your organization can actually see this particular project. When I click on Create, it is creating so much more than just a source control. It is creating your work item tracking, test case management, your build automation, your package management, continuous delivery, test case management, all built inside of Visual Studio Team Services. This is completely cross-platform. Our build and our release agents work on Mac, Linux, and on PC, and allow you to target any language, targeting any platform. So I want to make sure if you don't remember anything else about this video, please remember that Visual Studio Team Services works for any language, targeting any platform. It's not just .NET. So what you can see here on the screen is that our project has already been created. Now what I want to do is go get some code. And what I really like about our new system here is the fact that I can import from an existing repository. So let's say, for example, I have code out in GitHub that I would like to then pull inside of Team Services. This is great if you're currently paying for Git, because we give you Git as part of Visual Studio Team Services absolutely for free. So there's no charge for private repos. So simply click on Import, and what we'll do is we'll go grab your repository from an existing place where you might be paying for it and pull it into Team Services where you now have access to it for free. In this way, it gives you a high level of fidelity and traceability amongst all of the different features of Team Services. With your code inside of Visual Studio Team Services, you can now attach bugs and features to the commits that you make, tying them together so that in the future, I could go back to a commit or go back to a work item and see exactly what lines of code were changed. When a CI build is triggered, it will be able to show me all the bugs and features that were actually completed within that particular build. It would then be able to take me down to the exact line of codes that were modified in that particular build. This continues as the packages created by our build system then get handed off to our release system. We might have also checked in code into our package management. We have NuGet support and NPM support so that you can actually produce packages internally that are going to be used by other internal teams without ever having to push them out into a public repository. Once they're inside of release management, we're able to then deploy them to any platform. Of course, we want you going to Azure, and we have great integrations to get you into Azure. Our release system can even be surfaced inside of inside of Azure, that shows you when release management has done particular deployments, so you can correlate that with your application insights data and see if you see a spike up or down that it relates to a particular deployment that you just did from within inside of release management. So if we return back to my desktop, what we're going to see here is that the code has automatically been imported. And this is just not a copy of your code. The entire source of this entire repo is now native inside of Visual Studio Team Services. What I really like about Team Services is how it kind of guides you to do the right thing. Once I created my project, it asked me how was I going to get my source code. And it gave me tons of different options to do so. And now that I have my source code, you can see up here in the right-hand corner, it's saying, why don't we go ahead and set up your build? It's guiding me down this path to be successful. If I go ahead and click on Setup Build, it's going to bring me to a wizard that allows me to create my initial build of this particular code. I want to point out here that if you scroll down to these templates, and templates are just a collections of tasks that we've already identified that will build different types of projects. And as you can see, we have Xcode for those who are doing iOS development. We also support Xamarin for Android and iOS. If you're already doing Android Studio, we have a build for that. If you're a Java shop, we support Ant, Gradle, and Maven. If you're already using Jenkins for portions of your build, you can actually leverage that as well. We have Node.js, we have Docker support, we have support for all these languages, and we even have support that aren't listed on this particular page. So whatever it is you're trying to build, you can probably build it with our tool system. So what I'm going to do is go ahead and choose Maven, because I know that the project that I selected from GitHub is a Java application. I'm going to be building a Docker image, so I'm not going to need to publish any artifacts. So what I'm going to do very quickly is simply delete these two tasks that I don't need. I'm also going to be using tasks like Bower to actually resolve all of my client-side dependencies. So what I can do inside of our task list here is just search for what I need. So I need a Bower task. And as I mentioned before, I'm going to be working with Docker. Now, this is a great example of what happens inside of Team Services. We update this every 3 weeks with new features. These two come from a Docker extension that we have in the marketplace. We've then wrapped these into the box so that you don't even have to download an extension any longer if you want to go ahead and play with some preview features. For this demo, I'm going to stick with what I know. So we're going to go ahead and use these Docker tasks here that come from our extension, which you'll still have access to going forward. Now what I want to do is make sure I do my Bower first. So I'm going to simply drag and drop my task where they want it to go. Now this Maven task is extremely powerful. By default, it's going to package whatever gets built, so a WAR file or a jar file. It's going to attempt to run all my JUnit tests for me. And if I wanted to, I can even go ahead and calculate code coverage. So let's go ahead and check that. Another thing that I know a lot of Java teams like to do, and we're starting to do it more and more with C# as well, is actually analyze SonarQube data so that we can calculate our technical debt. Now, granted, you're going to need to have a SonarQube server already set up, but we will integrate with it. And let me show you how, because I happen to have one. I'm simply going to click on this gear. That's going to allow me to create what we call a service endpoint. And a service endpoint allows us to securely connect to all these different endpoints and start utilizing that information inside of our build and inside of our release. For SonarQube, all I need to do is create a generic connection. So what I'm going to do now is basically put in the information for my SonarQube. I'm going to then put in my SonarQube username and my SonarQube password. And simply by clicking on OK, I now have a secure connection between Visual Studio Team Services and my SonarQube. Now I can go back to my Maven task, refresh this, and now I'll be able to see my SonarQube in this particular list. By selecting it, this Maven task will not only download my code, build my code, run my unit tests, calculate my code coverage, but even share that information with SonarQube for me automatically. Now it's time for us to start building a Docker image. When you build a Docker image, there's a couple things that you have to be able to do. First, build the image. After you build the image, you need to store your image in a registry. And probably the most popular one to date is Docker Hub. But inside of Azure, we also provide Azure Container Registry, which is a private registry for your Docker images. Once your images are safely stored there, you can then pull them down to any Docker host in the world and start utilizing them. Because my Docker host is also in Azure, putting my images in a registry in Azure is going to allow me a very quick way to deploy my code because they're going to be sharing an amazingly fast network and they're going to be very, very close to each other. Now to do that, just like I did with SonarQube, I'm going to have to make a connection between my Docker registry and my Docker host to Team Services. So just like I did before, I'm simply going to click on the gear. From here, I'm going to then choose to create a Docker host connection. And I'm just going to go ahead and enter in the information here. So I'm going to put in the Docker host URL and the name. And now what I'm going to have to do is create my certs. Well, I've already created them, but I need to connect them because my Docker host is secured. And for us to be able to talk to it, we need to make sure it knows that information. So what I'm going to do here is just copy and paste in my information. And now with that information copied and pasted, I can now make a secure connection between Visual Studio Team Services and my Docker host. But I also want a Docker registry where I can store and retrieve the images that I build. I'm going to be using ACR, which is Azure Container Registry. So what I need here is my username, and then I also need my password. With that information, I can now have a secure connection to not only my host, but also to my registry as well. With that done, I can return back to my task here, simply refresh this list, and now I'm going to have access to my container registry, be able to tell it that I want to build an image. Inside of my repository, I have a Docker file. And then my build context is going to be a folder on my build server. And the image name that I want to create, I can simply provide. And then finally, I need to tell it which host do I want it to actually build on. And I'm going to be using my own private host, but you could also use our Linux-based hosted agents, which have the Docker tools installed. What I'm going to do now that I've built my agent is I need to then publish this agent to a registry. So I'm going to simply come over here, choose the same registry, change my action to push image, tell it the name of the image that I want it to push, and then simply tell it which machine upon which it should be doing the push, which is my Docker host. So now I'm able to resolve my Bower dependencies, run my build my image, and then push that image to a repository. Now all I have to do here is save and queue. Now I want you to remember, I'm going to use my default one, that this is a build that's going to be running every single time I check in code for a Java application. This is not just for .NET and for Windows. This is for any language targeting any platform. I cannot say that enough or stress it enough that if you're a Java developer, Node.js, Python, PHP, Ruby, Go, whatever language that you're wanting to program in, You can store your source inside of Visual Studio Team Services, build it with our build system on any platform that you want, Windows, Mac, or Linux, and actually deploy it to any platform you want, on-prem or even in the cloud. Just because Visual Studio Team Services is in the cloud doesn't mean you're restricted to deploying in the cloud. We can deploy to your Android, your iOS development devices, we can deploy to your on-prem resources, and we can deploy to your cloud resources as well. So now what it's doing is it's actually running my build. And what I want to do, I went over my build kind of quickly. While this build is actually running, I want to take you back and show you some other things that we can do with our build definition. For example, I want to make sure that I enable our continuous delivery, or continuous integration, excuse me. I simply click on this button here, and now every time I check in code, it's automatically going to build this particular build. I also want to tell it that every time you build it, please use my default pool. The hosted Linux preview, and hosted VS 2017 are build machines that live in Azure. They're sitting there waiting for you to ask them to do builds. The default pool, however, is empty by default, but then allows me to add additional agents of my own on machines that I control. I can have those machines behind my firewall on premise. I can have them in the cloud in Azure. All I have to do is install an agent, register that agent with Team Services, and then that machine becomes available for me to do my builds upon. I can make this a really big machine with lots of cores and lots of memory. I can drastically reduce the amount of time it takes me to do my builds. I can also cache dependencies on there and even install pre-release software on that machine should I want to start playing with beta or alpha bits of a particular product. So having a private build agent is a very powerful feature that we provide inside of Visual Studio Team Services. I can go ahead and save these changes, and let's go back in and see how our build is progressing. So from here, I'm simply going to click on Summary. And then from the summary here, I can go back in and see that my build was successful. So if I click on this build, what's really nice here is that I see everything. I get to see my test results, I get to see my code coverage, and I even get to see the fact that we sent information off the SonarQube and all my quality gates were actually successful. So this is a really great integration between all the tools that we're using. And like I said before, it saw that I had a project and asked me where did I get my source code. Once I gave it source code, it asked me to create a build. Now that I've had a successful build, it's asking me to create a release. It's guiding me down that pipeline of let's get your code deployed somewhere successfully. Just like in our build system, our release system has lots of different templates that come right out of the box that deploy all different types of applications for you to Azure. If you don't see what you need here, you can actually simply create an empty template, which is what we're going to do today. Visual Studio Team Services has everything that you need, but you don't have to use it all from us. If you're already using Jenkins as your CI system, as you can see right here on the screen, we allow you to pull artifacts directly from Jenkins and use them as part of our Visual Studio Team Services release. I'm going to check this box, which now gives me continuous deployment, which means every single time a build is done, this release is automatically going to go ahead and kick off. Now, when I create that, it's going to create for me a release definition. I'm going to change the name of this environment from environment 1 to dev. I'm going to change this here and give it a more meaningful name like CD for continuous deployment. And I can actually control, again, like I did on my build, where do I want these to run? And again, I want this to run on my default agent. Because I'm doing Docker deployments and all of the artifacts that I need are now stored in a registry, I don't need to download any artifacts as part of my build. And I can even have my release skip that part, save me a little bit of time. Now, all I need to do is add the tasks necessary to deploy my Docker. I'm going to go back over here to our build task. I'm going to scroll down to my Docker task here. I'm going to add 2 of them, and I'll explain why in just a second. The first thing I need to do is make sure that my build host, or my Docker host, excuse me, is not running an image that needs the exact same ports that my application that I'm trying to deploy to does. And I know that it does for now. So what I'm going to do is simply come over here and show you what's running there now. So this is what's running inside of my Docker host on port 8080, which is where I want to run my new image. So the first thing I need to do is stop this one from running so I can start another one. Otherwise, I would have a port conflict. So what I'm going to do here inside of my definition is simply give it a registry, tell it that I want to run an arbitrary Docker command, and the command that I want to run is going to remove the image that I know happens to be running there, and it's called Java demo. I'm then going to come over here and tell it which machine to do that off of. Now that I know that the image is no longer going to collide with the ports, I can then go and run another one. So I'm going to say run an image. I want to give it the image ID. And then what I'm going to do here as well is tell it the ports that I want it to run it on, which are going to be 8080. I want it to replace the Java demo container that we were using before. And I need that to run on the exact same host that we've been targeting for the rest of this. Now, if I wanted to, I could quickly come in here and clone this environment and repeat this for a QA or dev or production environment. I could also come in here and assign approvers. Approvers are individuals or groups that I want to have control over this particular environment. Let's say, for example, that you're a QA team and you have an environment just for QA. As your team are building CI builds, you don't want every CI build to go rushing inside of your QA environment, because if you're in the middle of testing the current release, you'd be getting bits that you really don't want to test, and it would invalidate your current test results, and you'd have to start over again. So what we allow you to do is be an approver of a particular environment, such that the builds will have to ask permission to enter your environment. And if and only if you give them permission, will the builds then enter your environment automatically. You can even schedule these. For example, I might be Wednesday, I'm testing some code, I know I'll be done on Friday. I get a request for new builds, and then during their approval, I can say, yes, I approve this code, but I want it to be deployed Friday at midnight when I know I'll be home. And then Monday morning when I come into work, I have a fresh new set of code on my QA environment for which I can start testing. This can be an individual or a group or a collection thereof. It gives you complete control and flexibility over what the approval should look like before code enters or leaves an environment. If your QA team goes off and does a lot of functional and manual testing, and then they find out that there's a lot of technical debt or bugs there, they can actually reject it on the way out, and it'll never see staging or production. So it's really nice to be able to have this level of control. Even though your deployment is completely automated, we allow you to inject people where necessary and have the tool monitor all that for you. What we're going to do for this video, though, is we're just going to create a single environment. Now, I feel that I am done already, so I'm going to go ahead and click on Save. And when I do, what's going to happen is we're now going to have a completely new release definition. Every single time a developer checks in code, the code will be built by our CI system and deployed by this release definition. But I don't have to go make a code change. And this is a neat feature because let's say, for example, you deployed a version of your code and bad things start to happen, and all you wish you could do was deploy the previous build over again. What I've just done by creating a manual release is exactly how you would do that. All of your previous releases or builds would all be listed in this dropdown. You could choose whatever version of the code you wanted to and simply click on Create, and we would happily go back for you and deploy that old version of code inside of the environment that you've selected. If I go over here to the logs, you can see that it shows me in real time everything that's happening on my server. We've already run the command, we've downloaded the new image. And if I were to come back over here where I had Hello World and simply refresh it, what we should see here is a completely redeployed image that is a completely different application using Visual Studio Team Services. So here we have it, a Java application being deployed to a Docker container from inside Visual Studio Team Services, proving that we can do any language and any platform. Thank you so much.